Uh, Good morning and good evening, everyone. My name is Anand Chandak, and I am a principal product manager on Nutanix database team. I welcome you to today's Tech Talk on Streamline Database Provisioning with Nutanix Database Service. I am joined by my colleague Adil, who is a senior engineer on the NDB product team. I also have my colleagues who are monitoring the chat queue, and together we'll walk you through the complete Oracle RAC provisioning workflow with NDB. Now, before I start, there are a bunch of things that I want to call out. So there is a poll running here. So you should see the button at the bottom of your screen. There are three questions. Just we'll all take a minute to answer the questions. And while you are answering, the other important bit information is we have it. Like I said, I also have my teammates and colleagues who are monitoring the chat queue. So if you have any questions at the time of the presentation, I would recommend you please post those questions on the chat queue, and someone from the team will reply to your queries. Right? And at the end of this presentation, we'll stop for a Q&A, and if there are any unanswered question or any other topic, then we'll take those questions then. All right. So we have four key areas to cover today. First, I'll introduce you to NDB and its core capability. Then I'll walk you through the provisioning journey step by step. Next, we'll dive deep into how Oracle NDB specifically handles Oracle RAC. And this is where it gets interesting for Oracle DBAs. Finally, we'll see everything coming together in a live demonstration of RAC provisioning. So let me introduce a Nutanix Database Service or NDB. It's our database automation platform. NDB transforms how you manage database through five key areas of automation. The first is the intelligent provisioning. You can deploy production-ready databases in very quickly with automated best practices built right in. Second, thin cloning technology that creates instant space-efficient copies for development and testing purposes. The third is around the automated lifecycle management, including patching, scaling, and maintenance window. Fourth is an ability to take enterprise-grade backup and recovery, as well as point-in-time restore capabilities. And finally, the security and compliance. The platform supports all major database engines, from traditional Oracle and SQL Server to modern PostgreSQL, MongoDB, and MySQL. You can manage everything through REST API, CLI, or our intuitive GUI, as well as there is a Kubernetes operator available for select engines. And you can deploy across the entire hybrid infrastructure, be it on cloud or on-prem. So for today's session, I'm going to be focusing on provisioning as the primary automation use case. And I'll use Oracle as our database choice of the engine. All right. So now let's dive into the provisioning journey with NDB. So provisioning in NDB follows four main steps. The first step is creating a base VM, what we call as a gold image. So this image is what you essentially supply to NDB. It should have the base OS installed. So if, for example, if you're doing an Oracle grid, so it needs Oracle grid and RDBMS software, as well as the Oracle, the NDB user that we'll use to minimally be set up. The next step is we register this provision VM with NDB. Now this registration process essentially tells NDB where everything is located and how to access the Oracle software. So you simply provide the VM IP, the grid, and the RDBMS home directories, and you configure the NDB credential. That's all. There's no manual scripting, no complex config. It's just a simple form-based setup. Next is about profile creation. Profiles are the heart of the provisioning journey. There are four different types of profile. And I'm going to be walking you through all of them one by one. The first one is what we call as a software profile. Software profile is essentially created from the VM that you registered, right? It's basically a point in time snapshot of the registered VM template, and it makes it available for provisioning. What this does is it ensures that every database deploys uses the same exact software configuration. There are no drift and no inconsistencies. Next is we create the compute profile. The compute profile defines your hardware specifications. You specify the vCPUs, the memory, core per CPU, and so on. This is where you standardize your sizing options. So instead of every DBA having to figure out what the optimal configuration, what you're doing is you're creating a standard small, medium, large type template that matches your performance requirements and governance policies. The third type of profile is the network profile. The network profile handles all your VLAN configuration and network segmentation. So for Oracle RAC, this is absolutely critical. You need proper separation between the public and private networks. And NDB handles all the complexity of the scan IPs, the WIPs, and the interconnect configuration, and so on. So you define it once, and it is applied consistently across every time. And the final type of profile is the DB parameter profile. This lets you standardize your Oracle configuration. So you specify memory setting, any initialization parameter, the SGA, PGA settings, right? So the idea is instead of having to tune each databases, you create profile that applies your best practices and performance standard. This way you eliminate any drift and you ensure that you have the optimal configuration set up right from day one. So after creating the profile, the next and the final step is provisioning the database server. So in our case, because we're talking of Oracle RAC, so which is where I'm showing you the Oracle RAC screen here. But if this was any other engine, and mind you, the steps are same if it was any other engine, be it Postgres, Mongo, and so on, right? So at high level, they all stay the same, but there are engine-specific parameters like I'm showing on this screen here. So when you're provisioning Oracle RAC in the payload, you select the profile that you created in the earlier steps. You specify what's the cluster detail, right? Like how many rack nodes, how many VMs you need, the type of the ASM driver. We support the following three drivers that you see on your screen: the ASM leaf, ASM FD, or UDEF. You specify the rack topology, by specifying what's the scan name, what's the listener port. You specify the database specific parameters. And finally, you specify the time machine. Time machine is our way to take backup, perform the backup and recovery. Right? So you specify what's the backup frequency and what's the retention policy. There are other profile, and we're going to be walking through all of this in a lot more detail in the demo. So now this gets very interesting, right? After submitting the rack profile request, I'm going to walk you through what happens behind the scene, when you submit the rack provisioning request. So what you see in your screen is I have a NDB server, which is actually registered with the Nutanix cluster, which has a direct the Nutanix distributed storage fabric attached. So this slide is very interesting. It's an animated slide, and I'm going to be walking you through step by step as to what happens behind the scene. So the first step is where, like I said, you initiate the request via NDB UI or CLI to provision a rack server. This request hits our NDB server. The NDB server internally orchestrates and allocates the provisioning workflow. So the first thing that we do is, for example, if you are spinning up a 3-node rack cluster, right? So we spin up 3 VMs, as you saw on the screen. And this is one of the differentiation here. For example, we parallelize this. To cut down the provisioning time, we parallelize this. So we spin up the VMs, and it has this a small monitoring software, what we call as a NDB agent, which is essentially managing the entire lifecycle, is attached. Now we get into the details of the rack provisioning. The first step that we do is we set up the network, right? So we set up the scan IPs, the public IP, VIPs, the private IP, and the private interconnect. Okay. So for those of you who have done rack provisioning, you know how critical this is, right? Making sure the IPs are allocated correctly, right? You have to work with the network admin team and so on, right? So all these are extremely complex. The next step is the software disk attachment, right? So we attach OS, grid, and RDBMS. And this is all coming from the profile that you've specified. All of these are attached to each VM, all in parallel, all concurrently. The next step is where we set up the shared storage configuration. Essentially, we are setting up the ASM shared disk group, the data disk group, the record disk groups, the CRS disk group. All of these are mounted across all the rack nodes in parallel. Now, then we set up the ASM cluster receptor on the grid disk across the cluster, across the nodes. We set up the RDBMS software on each node in the cluster. And finally, we create a rack instance which is spanning across all the nodes. Now, once this is all done, the next step that we do is we register this rack cluster with our metadata on the NDB server. Right? And finally, at this stage, you get an option to enable the time machine. Like I said, time machine is our state-of-art technology which allows you to take fast snapshot and do point-in-time recovery and so on, right? So you enable the time machine, right? So when you do that, as a part of that, we attach a staging disk that's going to copy the archive log on each of the DB nodes and is going to push this to the log drive on the control plane side. There is also an option to move it, to copy this logs to the object store. So as you see, with this 11 step, what I've shown you is an extremely complex rack provisioning workflow. It involves multiple groups like the DBAs, the network admin, the storage admin. So with NDB, we have eliminated a lot of complexity by combining this actions under, and we've cut down a lot of manual complexity that usually happens with the rack deployment. So now that we've seen what happens behind the scene, I'm going to talk about why NDB for rack provisioning, right? So as you saw, what we do behind the scene, right? So for those of you who've set up a rack, this can get very complex, in this slide, what I'm going to talk about is why we should use NDB for rack provisioning. So what I've done is across the next two slides, I have outlined the critical rack deployment steps. Now, I'm not going to go through all this point in the interest of time, but I'll highlight the ones that cause the most problem and how within NDB we eliminate some of these problems, right? So the first step is about the disk discovery. So when you set up the red column essentially shows the manual step that you need to do, and the green is how NDB performs the same workflow, and the blue is where we highlight what's the value that we add as a product here. So in the step one, disk of doing the disk discovery, right? So manually your DBAs have to scan the LUNs, map multipath devices, configure the UDF rules on each node. Now, this is where it gets problematic. If one permission error can kill the entire deployment, right? So with NDB, we auto discover all the eligible devices and set the permissions correctly across all the nodes. So you avoid any device mismatch or any kind of a permission error. The next step is around the grid infrastructure, and this is really a big one actually. When you manually deploy a rack cluster, what that means is you're going to be running the Oracle GI installer. You'll be setting the scan addresses, the VIPs, configuring the user equivalents for passwordless SSH, and this is where most of the rack deployment fails. NDB provides automated cluster installation and complete network configuration. So as I move along, in this slide, I have highlighted the other set of the typical pain points where of the rack provisioning. So as you can see in the step 5, right, and which I mentioned as I was talking about the architecture diagram is the scanning WIP, the scan IP and the WIP configuration. It involves a coordination with network team. You need to validate DNS. You make sure the floating IPs are manually configured and so on, right? So all of this is eliminated using NDB. We set this all in automated fashion, so you avoid the common IP conflicts and so on. The other critical point is around validation and health check. So when you deploy manually, what that means is you have to run the cluster verify command, ASMD command, and bunch of other commands to make sure to perform the validation of the cluster deployment. Right. The problem is if there is any issue with the deployment, it surfaces too late to fix it. Right. Whereas with NDB workflow, we auto execute this validation command at each stage. And if there is a problem, it surfaces early. Right. So what you get is a more predictable, reliable outcome, and it kind of way to catch the error early rather than failing at the foundational level. And finally, error and rollback. So when any manual deployment fails partially, the cleanup is essentially complex and time consuming. The NDB has a retry capable workflow with graceful rollback options. So it kind of minimizes the downtime and give you a consistent, reliable setup. So as you can see across all the 9 steps, you see the same pattern. Manual complexity eliminated through NDB's automation. Right? All the manual steps that I've highlighted requires weeks of coordinated effort, and they get eliminated with NDB's automation. What that means is your DBA can focus on high value tasks, like database tuning and leaving the provisioning on us. Now, with that, I will pass to my colleague Adil, who's gonna do a demo. We'll set up a live rack cluster for you. Adil, over to you.
Thank you, Anand. Thanks for laying the foundation of how NDB simplifies the rack provisioning orchestration, and also highlighting the differences and drawing a parallel of how traditionally rack is done and how NDB simplifies that. So without wasting time, let's straight away get to the live demo and see all the things that Anand has spoken in action. Before I start, I encourage everyone to, if you have any questions, please drop your questions in the Q&A of the chat box, and our panelists will be happy to answer them. Yeah, so let's dive in. So is everybody able to see my screen? Anand, can you confirm that?
I don't see the screen.
No, we don't see it.
Okay, let me just do it again. Is it visible now?
There we go.
Yes.
Okay, perfect. Yeah. Okay. So the screen that you see on my, on your meeting invite is basically the NDB console, and I'll just log into the console. The intent here is not to show you how NDB is installed or anything. There are a lot of capabilities of NDB, but for this session, we will particularly focus on rack provisioning, all the entities that are related to rack provisioning, like profiles that Anand has spoken about, and we will dive in how these profiles can be used to create a rack cluster. So as Anand mentioned, profiles are the heart of NDB, and these become the prerequisites for any deployment that you do with NDB. Now, as Anand mentioned, there are a couple of profiles, that are you need to set up as a one-time effort in order to be able to deploy Oracle RAC, or for that matter, CHA or SIDB. On my left-hand side of the screen, you see the profiles. One is the software profile, compute, network, and database profile, database parameter profile. For Oracle, we need to set these 4 parameters, but the Windows domain is not required since it's related to the MS SQL. The first thing is the software profile. Let me just log this. Okay. So as Anand mentioned, the software profile basically, onboards your operating system, and then the database version that you would like to, use for deployments. So in our case, let's take an example. Let's say, for example, you have a requirement where you want to, deploy a database with OS RHEL 8.10, and then you have requirement of 19C with patch level 19.26. So how would you go about doing this with NDB? So the first step that you would do is you will basically go to software. You will then choose the software profile creation, whether you want to create for single instance and rack database. We generally, with single instance database, you have an option. You can deploy all the three types of databases, which is your SI, which is your CHA, and then rack. So here I'll choose single instance database. And in order to create a profile, you will be asked about, you need to have a gold image template. This template is basically created outside NDB. And what you need to do is you need to basically install operating system of your choice and then the software that you need. So in my case, let's take a example of the same thing that I have just shown you. Now, this is my VM, which is outside NDB. And as a one-time effort, I need to create a VM outside NDB, and then we can register this with the NDB. So if you see on my screen, so we have RHEL 8.10, as I mentioned, and then if you see the grid version, so I have grid 19C and then Oracle DB Home 19C. And also, as I mentioned, right, you can have patch level of your choice. Yeah. So here I have 19.26 patch level with grid and RDBMS installed on RHEL 8.10. Now, if I want to, go ahead and use this for deployment, for the deployments done with NDB. So what I need to do is I need to first onboard this VM to our NDB, basically the NDB service that we are using. And one important thing that I want to highlight is, now there are different types of deployments that you do, right? It could be a single instance with file system, you could have Oracle restart, or you could have rack, right? Now you don't need to create separate templates for each of them. In my case, you can just have one template, and this template will serve for all the different database types that you are trying to provision. Bear in mind, if you want to use ASM-lib, then you also need to install the RPMs that are required for Oracle ASM-lib. You don't need to basically configure Oracle ASM. You just need to have the RPMs that are required for the ASM-lib installation. Once these are there in the VM, NDB is capable enough to identify that and give an option during deployment whether you want to do an ASM-lib installation. Now let me take this and let's say the VM is there. Now what you basically do, first step is you basically have to go to DB server VMs. I'll just quickly walk you through the registration process. You then register this VM that you just created. So for me, I created a single instance Oracle restart. You select the cluster. You select the IP. So in my case, this is the IP. You then select a user. So NDB also requires one user, which has a sudo access with no password permissions. This is required in order to ensure that all the commands that it needs to run in terms of formatting your disks, attaching IP, configuring all other things that needs root privilege. So we basically have a prerequisite that you need to have one user with sudo access. And then Oracle Home for, in my case, since this was the Oracle Home and this is the grid home. And then I choose grid home and then the password of this particular user. So that's all the information that needs to be given to the NDB to register your template VM. If I click on next, you can skip this automatic patching for template. We don't need this. You can say register. Now at this step, what happens is NDB runs some prerequisite checks on this DB VM. It sees that it is compatible with to be registered to NDB and manage the further basically do management on that server. So once this operation is complete, you should see something this is just a warning. If there's any warning, it will show up here. If there is any error, it will not allow you to register. So since it's a warning, I'll just close it, and you will see an operation triggered here for registration. So while this is registered, let me just show, I'll not wait for registration to complete, it might take some time. If I go to DB servers, you will ultimately see this server that we just registered somewhere in this list. Now, for our demonstration's sake, let's say the server that I just registered is, let's say 19.27. Now, if I go back to software profiles, create, come back to here, instance, let's say this is a rack profile. Let's say this is software profile 19C. I choose the cluster, and then you can see the template VM here. You click on next. You can fill in these details for your description for identifying purpose. You say next. Depending on the number of clusters you have, and if you want this software profile to be available across clusters where you can deploy databases using these particular software profiles, you can choose these options. So if I choose, I want this software profile to be visible across all the clusters, I click create. At this point, your software profile operation will get triggered. And if you see one of the operations that I have just done some time back for demonstration purpose. So basically what it does is it pre-processes your the VM that you're trying to create software profile with. It identifies the OS, it identifies the RDBMS version, the grid version, and then it collects all the information, and we have our metadata repository where we store all this. So at this point, even if you now go back and switch power off your VM, we will still be able to do deployments using this software profile. So software profile and the gold image or the template VM doesn't have any correlates after it is created. You can just power it off, keep it, just to preserve some resources. So this is at the end, once the software profile creation is done, you should see something like this software profile section here. So let's say this is the software profile that we just created. Well, so yeah, so basically once it is done, you will be able to see information about that software profile. So in my case, it is RHEL 8.10, database version is 19C, patch level is 19.26. You can basically do a search, find patches of your interest if you are looking for any particular patch. Similarly, for grid infrastructure, 19C, again, the patch level will be visible here. And then it also shows you what are the servers that are provisioned using this particular software profile. So in my case, there are some existing rack deployments that I have done, and you can see these are the VMs created out of this software profile. And then availability. This software profile is available on which all clusters where you can do this deployment. So all the information you will find under the software profile tab, and it gives you a basically overview of what the software profile contains, what is the version, how many DB servers are created out of this. And there's something called as published and unpublished. Basically, published is, this is basically if you have end users using this profile and you don't want to see them, the new profile that you create, or if you want some users to only see particular profile, that's where this published and unpublished comes in picture. If it is published, they will be able to see that new version. If it is unpublished, only admin can see this particular version. So this is all about software profile. Moving on, we have compute profile. Compute profile is straightforward. You basically, depending on the environment that you want to create profile for, let's say it's a dev or it's a production, you define your vCPUs, you define your cores, and then the memory. So in my case, I have defined some, let's say I have defined compute for dev, which says vCPUs 4, cores 2, and memory 8. Likewise, for different environment, for different application, you can set up your compute profiles. Next up, we have network profile. So for network profile, I'll just quickly touch upon, before we create a profile, how actually you can utilize network profiles. So if I go to settings, if I go to networks, so basically you should see, let's say you are managing 3 clusters, right? So in my case, since I have multi-cluster, let's say I have a DR cluster and I want to use particular VLAN from that cluster, right? So what you do is you select your cluster, import the VLAN that you want NDB to manage for you. And that VLAN could be assigned to different databases, different depending on production or development, whatever use case it has. Let's say in my case, let's say there's one VLAN which I have not imported, and I want NDB to manage this VLAN. So what you do is you select the VLAN. If it is IPAM managed, it's a DHCP managed, then you don't need to fill in this information. But let's say this was a static VLAN and you want NDB to manage this through particular gateway, particular subnet mask. So you fill in this information, You give the IP pool, and then you can import this. For my case, this is DHCP, so I'll let it unchecked. I click on add, and it does some pre-read checks, and finally you can see it got added here. And I just wanted to highlight one more thing, and each VLAN could have different IP pools, right? So let's say you want particular IP pool to be managed by NDB, and likewise you can add different pools here. So basically if you click on add, you can add different pools. So this is how NDB gets to know about which VLAN NDB should use and what are the pools that NDB should use. Now heading back to network profile, once you have created your network profile, you basically go to Oracle. If you are using for single instance, you select the DB server VMs, but since we are focused on rack, I'll just go for rack. In this section, you basically name it, let's say this is rack profile demo, and then you select the cluster from which the VLANs are being imported, and then select the VLANs. Now, in case of rack, since everybody who is aware of, who has worked with rack, we need a kind of, multiple IPs for public IP, VIP, interconnect, and then the, scan IPs. So here, if you select your static VLAN, by default, it populates the public VLAN across the public, virtual, and scan. You can even, if you have multiple VLANs, you can change this. And then the private VLAN, in my case, would be this one. Once you have done this, you can click on create. And at the end, you should see something like this. So it says that, okay, for this particular profile, these are the VLANs that it should use. And eventually, it will pick up IP pools from these VLANs. So this is about network profile. And the last up, we have database parameter profile. Now, while the first three, software, compute, and network, deals with the, the creation of VMs, the resources on the VMs, the network on the VM, the database parameter profile is strictly related to databases. So once the VM is created, what should be the structure of a database? What should be the SGA for database? What should be the PGA? What should be the table space size for temp, or be it undo or default language? So we have a limited set of parameters here for DB param profile, but we also have a way to add, even more parameters through CLI, through API, but not through GUI. The reason is we wanted to keep this limited so that, bare minimum necessary parameters are filled, and which can eventually help you to create database. So in my case, if I go back here, I have created two parameters for demo. One is prod, which basically says that, these are the parameters, like I have set SGA like this and temp, all those things. But if you see dev, I have created one custom parameter called audit_trail, which is not there in the list you saw in the GUI. So what I've done is I have done it through a CLI where I add a custom parameter. So likewise, if somebody is interested to add a few more parameters because their deployment demands additional parameters, they are free to update parameter profiles as per their choice. So at this point, we have covered all the 4 parameter profiles. We have seen how to onboard software, compute, network, and database parameter. Now let's go and see how these profiles help us to deploy Oracle RAC. So I'll head to databases. I'll go to source databases. And here you see we have an option to provision. And when I click on provision, you get, as Anand also spoke, that apart from Oracle, we have support for various different database engines. So in my case, let's go with Oracle and RAC database. Okay. As soon as you land up on the provisioning of Oracle RAC database page, you will see 2 options. One is create new cluster, and one is use registered cluster. So I will not go on registered cluster for now. I'll cover this at the end, but let's go with the create new cluster first. So at the beginning, so you will have to define the the structure of your RAC cluster. What should be the cluster names? For example, let's say this is RAC cluster for prod. Okay, and then let's say you want to deploy it on DR cluster. Since you might have multiple clusters NDB is managing, but you want to provision this on DR cluster. And the rack profile that we would have created, let's say this is the rack profile. If you highlight this, it shows that which VLANs it is importing. And then number of VMs you want to have for that rack. Let's say it's 3. And then each VM node will have a name, a particular name to that VM. We also, what you do is if you give a name, let's say this is demo rack, what NDB does is it adds up, a suffix to this. It could be 01, 02, 03, depending on the number of nodes that you would have chosen. And then finally, the software profiles that you would have created. So in my case, let's say I have created this particular one. And if you have multiple versions, you can click on update versions and you can select that. And then finally compute profile. So in my case, I'll use this, which says that 3 vCPUs, 2 cores and memory. You give the password. And then the driver. As I said, right, one particular software profile is enough to provision any type of database, whether it's rack, it's single instance with different drivers. So in my case, you can see there are different options, ASMlib, ASMFD, none is equivalent to UDA rules or multipath. So let's say I want to choose ASMlib. And then there is also, we spoke about NDB user, which has sudo access. In case you want to change password for that user on these rack clusters, you can update this. SSH public key optional. If you want to access this VM through public keys, you can upload keys here. And then moving on, we have rack topology. So you define what should be your scan name for that particular rack cluster. So let's say this is demo rack scan. You can change the scan listener port. By default 521 is the one you can, but you can change it anything that is allowed by Oracle. So I'll keep it 521 by default. Database name, let's say this is rack DB SID rack DB. The details that I'm filling here are related to database. So on this rack cluster, since we are also provisioning a database, this particular page is for the database details. And then do you want to create a CDB, PDB on this particular rack cluster for this database? I say yes, okay. You choose the option and then say PDB test. And finally, what should be the size of that particular database? By default, we have 200 gig across, Oracle, NDB provisions each database with 2 disk groups. One is data DG and one is record DG. So this is fixed and you cannot customize this. So there will be only 2 disk groups for standardization. So, but you are free to choose the size of your choice. For example, in my case, let's say it is 1 terabyte, FRA, let's say 600 gig. And then the database parameter profile that we would have created. So in my case, let's say I go with prod. This is the memory that it has. But since I use small compute, let me go with this one. Yeah. And then you can choose the character set and then the NCS. So I think these options you will be pretty much familiar with. This is how traditionally, if you do outside NDB or anywhere, if you deploy a database, these options are very common, I would say. And then NDB also allows you to use native TD wallet encryption. If you click on encryption, you can provide the wallet password. NDB will then go and internally configure a TD wallet for you, which is native TD with auto login enabled. I'll leave this out for now. And you also have an option of pre and post commands. So basically, let's say you are deploying a database, but as soon as the rack cluster is provisioned, you have a requirement to run some sort of checks before you actually deploy a database, or you want to create a user or do anything before you create database. You can utilize this particular section where in pre commands you basically have you can have a script, you can have commands directly pasted here, and what NDB will do is before provisioning database, it will go and run this particular section, and after database is provisioned, it will go and run post create command section. This is useful. Let's say after creating database, you have any you want to create custom table spaces, custom users, do some sort of security checks, or have some security enabled on database, you can use post create command. And then if I click on next, and then finally we land up on the time machine page. Time machine, as Anand said, it's equivalent to your if I have to correlate, it's basically a construct in NDB which manages your backups. Here we define the frequency of backup and the retention of backup. So in my case, I have different SLAs. By out of box, we have 4 SLAs: gold, silver, bronze, and brass, and none. But you are free to customize your SLAs. For example, in my case, if I say prod SLA, if I highlight this, it says that have a continuous archive log backup of 60 days, and then the snapshots of 15 days. You store weekly backups for 4 weeks. Like that, you have you can define your backup schedule and the backup retention on this page. Even if you don't define backup here, you can later go and update the same schedule. So if I click on next here, and then you also have an option. Let's say you have you have hundreds of databases running in your environment, and let's say NDB is managing, let's say, hundreds of them. And there is an and every environment, let's say, has 30-40 databases which you want to do patching in a single go. This is where maintenance window comes in picture. Okay, so if you select, say, once this database is deployed, you tell NDB that you make this part of database patching and schedule under this maintenance window. So what happens is, when this maintenance window is triggered, say schedule is monthly on Wednesday at this time, this database will automatically go into a maintenance window and database patching will be done. If you select operating system patching, it will also do OS patching on that. So you have an option to configure this at the provisioning time, or you can even go and do this later. So now at this point, I am done with the inputs. And if you would have paid keen attention to this, there are minimal inputs and which are very easy. Any database admin or non-database admin will also be able to provide these inputs. Now at this time, if I click provision, it will go and trigger operation. But before I do that, I actually wanted to show you how NDB also basically you can interact with NDB in 3 modes: CLI, API, and then the GUI mode that I have just shown. Now let's say, instead of using GUI, you are somebody who likes to provide database as a service, or you are somebody who likes to automate deployments based on certain user requirements. So what you can do is you can basically have a API payload like this, and it will help you to deploy the database. Now in my case, let me just copy this. I'll just close this. I'll just open just for demonstration. So I am using API Explorer, one of the API Explorer. Now, if I paste the payload that I have just copied, and if I say, so you can see, as soon as I paste it, you will see the payload the inputs that we gave, everything is in this payload. Now you are free to customize this. Let's say you don't want this name, you want something else. VM names you want to change, you can change the VM names. And basically you can have automation around this, and you can deploy VMs on the go without even having to log into GUI and perform operation. And this is true for all operations that you do with NDB. We have API first class feature for all the all the major features that NDB supports. Now by default it took post, and this is the URL that it has to redirect API call to. Now if I go to authorization, I select basic authorization. Basically it asks the input, and if I go here, and now if I click send, rather than doing it through GUI, I just copy paste it. So you can see it says, okay, operation has been triggered. This is the operation ID. Now, if I go back to GUI and let's close this, let's say close. Now, if I go to operations page, so you can see this was the operation ID, right? 3E6. So there is operation ID. See, this is the same operation ID that we just triggered. So you saw how easy it is to deploy, whether through GUI, through API, or through CLI. You can basically orchestrate your deployments. Now I'll not wait for this deployment to complete, because it will take around 1 hour or so. Let me just quickly show you one rack provisioning which I have done some time back. If I go to filters, filter from 5 days. Let's see if I have provision. Yeah, so here is one rack provision. So what you see on screen is I have done one rack provision some time back, and so this is what the page will look like once the deployment is done. So basically, if I have to quickly walk you through the steps, so basically it does pre-processing, where it validates your the names, the inputs that we have given. It validates the network profile. It validates the IPs that has been assigned, because it might be that IP is assigned but it's used somewhere else. So everything is done in pre-processing. If this stage completes successfully, then only it will go ahead and do other things. And then it will, let me just do this. Okay, so it then creates your virtual machines depending on the number of nodes. It does the network configuration. It attaches the storage devices for that, for CRSDG, for databases. And then basically sets up the user equivalence, which is passwordless SSH for Grid and Oracle user. It then performs the Oracle configuration. So basically sets up your clusters, runs the grid setup across the nodes of the rack nodes. And then finally the Oracle RDBMS installation, and then followed by the database installation. And as Anand mentioned, the final step would be to register this particular rack to NDB for management. Now, the steps that you see here is basically, there are a lot of other steps that internally does, like validation it does, and it ensures that whatever, once the rack is clustered, it does some checks to see if everything is good. And once those checks are passed, then only it will go and say, okay, the operation is completed 100%. So this is how easy it is to deploy rack using NDB. The only one-time effort is creating the software profiles. Now, quickly, I'll just go back to databases sources again. And if you remember, I said there is one more option called as use registered cluster. Now, basically what this means is if you click on this, now let's say you already have a rack cluster deployed with you, but you don't want, now basically you want multi-databases into a single cluster. So at this point, you will use registered cluster. You select the rack, any rack cluster that's already there, and then basically it populates the IPs of that and the scan port and everything, and rest of them follows as is what we did in the previous deployment. So this is how you can deploy database into a rack cluster. You can deploy rack cluster with database, and there is one more option. If you want to deploy only rack cluster without databases, so you go to DB servers, you click on provision, you click on server cluster. So with this option, you will be now able to provision only rack cluster without any databases. So you have all the three options available with NDB. Now, if I go back to, I'll just take 5 more minutes and then we'll go for Q&A. And if I go to database page, just to show you the layout. So let's say this was my rack database that I provisioned. So this is how it will look after it has been provisioned. So basically you have the database details here, the size of the database, the version of the database, number of nodes, what is the IP of on each node. You also see a tick here, which basically says that which of the node is being used for backups. Now, if rack is say 3 or 4 nodes, only one node at a time will be your source of backups for NDB. And if that node is not available, NDB will automatically fail over to the other node. And likewise, this is the time machine page, basically the database backup page that you have. And you will see the profiles which are used for the creation. You also see the pluggable databases that are created within this database. Now, if I go to the server cluster, which is basically the VMs that are being created, you will see we have a topology here which says that, okay, this is the scan IPs, these are the rack nodes, this is the IP, and this is the database within that particular cluster. And likewise, you will see the software profile versions and the profiles. Now, we have only touched provisioning here, but as mentioned, NDB is capable of a lot of other Oracle features like patching, like Oracle upgrades, and all these are one click. For example, if I'll not go into detail, but if I click here, you can basically go from 19C to 21C with just one click. And likewise, you will also see an update button here. If you click that, you can do patching. So this is the flow, how the orchestration of rack is done. And one last piece on the time machine. I know we are towards the end of the session. If I go on time machine, so basically this is how you will see the backups. If I have to lay, like understanding of how traditionally we do, you can compare these vertical bars as your level 0 backup, and all the green region that you see becomes your archive of backup. So in case tomorrow, if you want to do a restore or you want to do a clone, you can select any of the point within this region, and NDB is capable enough to restore or clone your database to any given point in this particular backup window. Yeah. With this, I'll end my the demonstration, and I hand you over back to Anand. Yeah. Thank you, everyone.
Thank you, Adil. This was very, very helpful. This was a great demo, and you just demonstrated the power of NDB. How we simplify with automation the provisioning of a very complex rack deployment, right? So I will once again go back and share my screen. Now here's a real very quick. I want to demonstrate the real world impact. So we have a very large international retailer, managing over 4,000 databases with NDB. That's about 50% of their fleet, right? So they've achieved self-service provisioning in very, very quick time with Oracle database, SQL Server, PostgreSQL, and MongoDB. This kind of represent a complete transformation from their week-long provisioning cycle to on-demand database delivery, right? Now, before we open it up for Q&A. I want to simplify. So let me sort of summarize the transformation that NDB delivers. You see, using traditional approach requires manual scripting, fragmented tools, or some homegrown automation, right? It requires a complex cross-team orchestration. One has to work. There are different teams that need to work together: infrastructure, storage, DBAs, network. All of them need to be in sync, work together, right? This manual process is error prone, inconsistent. As Adil and I, we spoke about, all the different kind of problem that you can land into, right? And it typically, you spend days or weeks, right? With the help of NDB, enables you to do self-service provisioning using GUI or API, right? We automate the infra and the database setup, right? For example, you saw how we managed parallelize the VM provisioning, spinning up VMs, grid, scan, ASM, all of that. It's all profile driven, so you get consistency, no manual configuration, no drifts, and it's extremely reusable, right? And what that does, it enables you to set up rack up and running in a few hours. So with that, I would close this. If you want to learn more about NDB, here's our QR code. You can scan it, and there is a test drive. Just look at our documentation resources. You can learn more about NDB. And with this, I'll open it up for Q&A. Jagdish, Altaf, if there are questions that are not answered, or if there are questions that can help the general audience, we can open it up.
Yeah, I think one question, I think for everyone's awareness. So the question was, in brownfield, customer can have different disk groups for a database. So how NDB will manage that particular database? So Anand, I'll go ahead and answer this, or you'll take it up.
Yeah, go ahead, please. Go ahead. Feel free, please. Go ahead.
Okay. So basically what happens is, so NDB can manage any database with any number of disk groups, but the only prerequisite is that the disk groups that are being used by any database should not be shared across different databases. So as long as a particular database is using any number of disk groups is fine, but that should not be shared within the other databases in that particular rack cluster. So it is supported, but with this restriction.
Thank you, Adil. Are there other questions, folks?
Yeah, Sudhir, if you have any follow-up question on that, you can please go ahead and ask that. So one more question is for everyone's awareness, how the time machine works. Is it Oracle native backup or RMAN? No. So with NDB, we don't use traditional backups. So basically, NDB uses its core technology, which comes from basically the storage snapshotting. And NDB is very smart enough not only to leverage snapshotting technique, but also leverages taking backups of archive logs. So archive log backup is taken traditionally how we take RMAN, but it's not used as how you would have used in traditional systems. So in case tomorrow, if you want to restore a database or clone a database, what NDB does basically is it restores your snapshot first, which is a lightweight in nature, and then it applies all those archive logs on that particular snapshot to bring in to the point that you would have requested during restore or clone. I hope, Rama, that answers your question.
And just to add, there was another iteration of this tech talk, Rama, which was specifically focused on time machine, right? So we can share the presentation with you. So my colleague from the product team, Raghu, was leading that demo. So we can share the link for the past tech talk that we have done.
I think there's one more question from Sudhir.
If rack is available, go ahead. Go ahead.
Yeah, if rack is provisioned using the restricted data record and CRS-DG as per documentation, can we add more disk groups to the provision DB, or is it not permitted? while we don't encourage addition of disk groups, because it basically limits the functionality of NDB. The reason we do disk groups is to make it a standardization across different deployments. But having said that, if somebody creates an additional disk group on top of what NDB has provision, it will work, but the problem will come during the scale operation. NDB will not be able to handle this particular use case on scaling. You might see rest of the operations working fine, but scaling will be challenging. So the direct answer is you shouldn't. We don't advise customers to do that. Yeah. Is there any other question? How about monitoring, incident creation, integration with third-party tools for ITSM? Yes. So NDB doesn't have out-of-box monitoring support for databases like monitoring queries and performance and all those things. But yes, all the operations that NDB does, be it deployment, be it patching, cloning, restore, you have basically a support for integrating it through for monitoring. So each operation, whether it's successful, it fails, depending on the severity, you can basically create alerts, and those alerts can be redirected to your emailing list, whichever you configure with NDB. So yes, monitoring for these particular use cases is there within NDB. Yeah, and just to add on a couple of things. So there are a lot of enhancements we keep working on. One is maybe customizing disk group names or supporting multiple disk groups. These are something that is already there are enhancement requests on these. So maybe down the lane in future you might see support across the requirements that you have just mentioned. Yeah. If there is any other question, maybe you guys can post in Q&A.
I think we pretty much answered most of the questions on Q&A.
There's a question saying that what about installation logs using CLI? So on the logging part, so every operation that NDB does, it captures all the logs, be it the the workflow logs, or be it the database specific logs. For example, if you're doing database installation, you are doing grid installation. So we have logging for all of these, and these logs are kept within that DB server which is being created. And if the DB server for some reason is rolled back because the deployment didn't go through, then these logs are copied to our NDB control plane VM and stored there. And then these can be downloaded for if you want to attach to support and do your triaging. So for each operation, yes, we have logging for all the steps that NDB does. Yeah, I think I have covered most of the questions here. One question was there on patching. Do we stage the patch, or do we restrict the patches that NDB provides in the drop down? Okay, so on terms of patching, what we do is, if let's say every quarter which Oracle releases patches, and let's say you created a software profile with 19.26, and let's say new patch comes in 19.27, 19.28. So what you need to do is you can go back to your gold image, apply that patch to the gold image, create a new software profile version. So as soon as you create a version of that profile, all the DB server created with n-1 version of that software profile will now see that new software profile available. And as I said, right, there is one click option for patching. So you just need to go to DB server, click on patching. So it will go and do patching for you. And just to highlight, NDB does out of place patching for rack, and it does it in a rolling fashion. So your services remain intact while it is being patched under the hood.
Okay, I think Adil, we are almost top of the hour. So thank you, folks. This was interactive session. As a part of NDB team, I thank you for joining this session. I hope this was helpful. Feel free to reach out to NDB product team if you have any more questions. Thank you.
Thank you, everyone. Thanks for your time and joining the session. Yeah.